Okay, so should be pretty straightforward for that one. Just gonna graph a line that looks kind of like this. And then remember, x equals -3. Is that vertical or horizontal?
Vertical.
Yeah. I know it's a little tricky because x is a horizontal coordinate, but it's actually a vertical line because all the x values are -3. So you should get -3 comma -1. That makes sense? We're good? Oh, okay. We're oh, yeah. Thanks. Appreciate it. Wow. Oh, come on, Karen. No, thank you. Appreciate it. All right. Next up. You probably want to get y by itself here. This one looks kind of interesting because if I do get y by itself for the first one, just drop the negative. You should have 4x plus 2. Then here, you should get 4x minus 4, I think. Is that right? Yeah. I think 4x minus 4. Let's get y by itself. What's going to happen with this situation here? If I graph it, yeah, they don't touch, right? So that's my first line. It looks a little messy. And that one, yeah, they just don't touch. So you can say no solution when they don't touch. Now, if they happen to be identical lines, like when I isolated y in each case, we got y equals 4x plus 2, y equals 4x plus 2, they are on top of each other. What would you say in that case? If one's on top of the other? Infinitely many, because so many. If they're the same line, because remember, a line has infinite points, right? If they're the same line, we say infinitely many. If that happens, when that situation happens, that's what we would say. Infinitely many. Here we're solving. You guys see the process, but it's kind of up to you what you want to do. I'd probably made these elimination for this one. Notice I'm multiplying both sides by 2. So you get 4x minus y equals 20. Negative 4x minus 4y equals 20 as well. Add them up. Negative 5y equals 40. So y equals -8. If y equals -8, you can throw it back into any equation here. You get x equals 3. Here, if I did substitution, let's say I get x by itself. You get y plus 13. Replace the x in the other equation with that expression. Work it out. You get 6y equals -42. Y is -7. Throw it back into either equation. Throw it back into this one over here. X equals 6. And remember, these are lines still, right? You can punch these in. These are lines. They see where they touch. So, all right. Factoring, always look for the GCF first, right? So 2 can be pulled out. You get 8x squared. Nope, sorry. 12x squared minus 5x minus 2. And I think it breaks apart as, she did say there's a mistake here. Okay. I think it should be broken apart like this. Then 1/4 and 2/3. So she forgot the 3. So just be careful about that. And then, oh, I see why she did this. Okay. I did something bad. What was not bad? It was terrible. I did more than I was supposed to do. What did the question ask for? Factor, right? Was I supposed to solve? No. So leave it alone when we get to this point. Why did I solve it? Because like you guys, I want to do more. Right? This is sometimes that we just think, oh, okay, here's a problem. Usually we are asked to solve this, so we can do more than we're supposed to do. But remember, you're not supposed to do that. You're supposed to leave it alone. Now, now you're supposed to solve by factoring. So it's the same thing as number 3, essentially, right? It's the same stuff that's going on here. But what you do is you bring everything to one side, and you still go through the same motions of factoring. So you wind up getting the same thing, but now it equals 0. So you guys see the difference between 3 and 4? 3 is asking to solve. Sorry, 3 is asking to factor. 4 is asking to solve. So 4 is asking to take an extra step. That's all. So anyhow, now when you're solving, one thing I want to keep in mind is that why do we have a factor in the first place? We're multiplying 3 things. What are the 3 things I'm multiplying? 2, this, and this. In order for this whole product to be 0, one of these 3 things has to be 0, but 2 is 2. We're stuck. So this has to be 0, this has to be 0. That's why I solve to see what makes the equation true, what makes it equal 0. So 4x plus 1 equals 0, x equals -1/4, or 3x minus 2 equals 0, 3x equals 2, x equals 2/3. So how are number 3 and 4 different versus the same? They're saying that the same expression for the most part. Like, yeah, you got like, A, B, and C are the same, but different because what the instructions are asking to do. So number 3 we say is an expression. Number 4 I say is an equation. Equation has an equal sign, right? So here you just factor. She definitely gave a lot of details in her answer here. But yeah, an equivalent expression, right? But here you actually solve. You actually want to get me a number, right? And she was kind of adamant about that because I think you guys did do that on your homework quizzes. Some of you guys went a little further than you should have. So just something to keep in mind. And then finally, these couple problems here. Just remember, if that's 121, that's 59. You got 112, so that's 68. That's also 59. So it's 99, which will make that 81. Yep. Then here, that's 125. So that's 55. Then that's, of course, 75. So you got 130. So this has to be 50. So hopefully you see the domino effect. Like that's why it's good to go through. It's nice to have this. It's actually nice to actually hear and see the step-by-step process, right? Like how when one domino falls, the rest fall, right? Then you get one thing, you get everything else, right? How was 7 for you guys at home? Were you guys okay with that? Good. Okay. Remember, if that's 102 and these are parallel, what did we talk about? Were same side interior, consecutive interior? What did we say was the relationship between these two? So yeah, this is 102, and this is some junk here. How are these two angles related? Are they the same, or they add to 180? Add 180, they're not the same. They don't look the same, right? One looks obtuse, one looks acute. So 102 plus that junk, which is 10x straight up, equals 180. So 10x equals 78. X has to be 7.8. Wait, what? Hold on. Did I do something wrong? Yeah, that's 180. What is she talking about? She made a mistake, right? Am I crazy? Yeah. No, it's okay. It's very nice for her to do. I'm just kidding. No, we all do that. I trust me, I do it all the time. So 7.8. So I'll let her know she has another error. 7.8. Yeah, and then once you get that, that's a little nasty. I really don't want to work that one out. Well, you could say this. You could say 5x minus y is the same as this because it's also parallel. So it's alternate interior angles. So you definitely want to see that connection. That's not as terribly obvious. But remember, we have a trapezoid here, right? Remember, trapezoids, we have one pair, just exactly one pair of parallel sides. So 3x equals 2y. And you want to plug in the 7.8, which is not fun. But you guys get the idea. I know you guys can solve that for that. So I'm not worried about the algebra. It's just more how to make the equation, right? Last one. So here's the deal. If that's 110, that's 70. So X has got to be 110. That means that's 70. 40 and 70 is 110, so Y has to be 70 also. And there we go. Okay, so all's good. Cool. All right. So let's do the new stuff. So I would say today's going to probably be the last day of the new material. Tomorrow, I'll actually want to do a review for our post-assessment on Friday. And I have some stuff for review here. And then I also want to do some practice, like go on the walls again, guys. So I really just want to use tomorrow to really just kind of sum everything all up. And then Friday, the session's not going to take all 2 hours, but they would just do some extra practice built math or something else. So you're not going to miss too much. Just, you know. But here's my notes for today. So today we're going to talk about similar triangles. That's kind of another topic on proportions as well. That's kind of what I'm thinking. Okay. Okay. Yeah, it's obviously a couple errors, but yeah, we can. All right. So this is some notes I found in one of my folders. It's a lot of stuff. It's actually probably a little too much personally. Hold on, I think I have it right here. Yeah, here we go. So just to kind of take a quick scan of this, this is like a bunch of different worksheets on proportions as well as similar triangles. We'll talk about similarity in a moment. I'm going to say let's do the evens because odds are provided. So if you want as extra practice for later in the year, you can check your answers after. So we're going to do the evens today. So today we're just going to do evens. We won't do odds. We'll do evens. And we'll kind of go through as much as we can until we get to the break. And some stuff I'm going to skip over because some are a little too much. And there's some other stuff here I want to talk about as well. And then after that, then we'll do more delta math and homework. So that's kind of the plan for today. So we got a lot, to kind of get through here. All right, so let's talk about ratios. Ratios are a big deal in geometry. So for example, if you're comparing 2 pounds to 4 pounds, how would I reduce that fraction? What would that become? 1/12, yep, that's all. So we're doing a reduction of fractions. Now let's take a look at number 4. $28 or $7. What would that? Just 4. 4 over 1. We got it. And then for this one here, 1600 over 5, that's a little hard to do in your head. But one thing you could do, what if you divide 1600 divided by 10? What would be 1600 divided by 10? But because we're dividing by 5 instead, I know it's kind of counterintuitive. So I'm doing 5 is half of 10, but because it's division, I have to actually multiply. It'll be 320. So what I did was I kind of assumed there was a 2 here, right? I kind of assumed that. So this right here would be 160, but then times 2 is how I get 320. That's why I do the mental math, by the way. I'm not actually doing this long division in my head and doing all this crazy stuff. I'm actually trying to think of like shortcuts, right? Like I know 600 divided by 10 is 160. You guys said that too, because you dropped the zeros. But because you're dividing by 5, that would be okay to like multiply by 2, because you're in a way going half of 10, which is divided by half is multiplied by 2. Now, really quickly, I know I said we're only doing evens, but be mindful of something like, say, number 5. You can't just divide it into 3 rows. Because there's not the same units. So you guys are on a curveball. You guys know how many yards are in a, sorry, how many feet are in a yard? Three. So you have to do 10 of 9, just so you know. Or for this one here, 4/10, how many inches to a foot?
Oh.
So you got to do 4,800 divided by 10, which would be, I think, be 480. If in case if you had to change the units around, just be mindful about that. Actually, speaking of which, let's look at number 8. Now, these are both equilateral triangles. So they're both in the same proportion. So you have 2 feet to 18 inches. How many inches is 2 feet? 24, good. So you 24/18. You have to use the same units. Very, very important. That'll be, they're both divisible by 6. So it's 4/3. Okay. You get 4/3. Uh, 14. A rectangle looks like this, right? Now, first off, what does perimeter mean? Good. Yeah, it's a very simple concept. All sides add up. And you're going to do a lot of that in geometry, right? All sides add up. Also, we happen to know that 2 of these sides are identical, right? And those are also identical. If I had to generate my own formula for perimeter, so we'll call this like width, length, and width. It doesn't really matter which one's which, right? It doesn't really matter. But if you think about it, if I had to generate my own formula, the perimeter would equal what? 2L plus 2W, right? So you have 3 variables. You have P, L, and W. Okay. So this is going to be a big part of how we incorporate algebra into geometry, right? This is a geometry problem, of course, shapes, perimeter. And even if you don't remember the formula, it's okay because you know perimeter means surroundings. You know what it means. And you know how a rectangle looks. So great. Now, one of these 3 variables I do know have a numerical value. Which of these 3 I do know? Okay, good. So 480. 480 equals 2L. 2L plus 2W. Great. 480 equals that. Awesome. Okay, before I go any further, can this equation be simplified? How? Divide everything by 2. So it's the same thing as saying this now, right? Okay, now we're rocking here. Okay. All right. But the problem is I got 2 unknowns. So when you solve equations, you need 1 unknown, not 2. It gets a little crazy. Is there another relationship? Remember I talk about relationships. Equations are relationships, right? So I know that the relationship between L and W is this. L and W have to support. Is there another relationship?
For every
Yes.
5 foot in length,
Yes.
1 foot width.
Yes. So L over W, that's a second relationship. That's an equation, right? That I can make. L over W, the poem just means divide. Okay. How can I manipulate that algebraically so I can use it to substitute? You guys remember this process? What is it called? Cross multiply. Yeah, we're not canceling, right? I know what you mean.
Yeah.
Yes, we could cross cancel at times. Cross cancels for multiplication, by the way, not for equals. If you had like cross canceling, just it's like something like this. You said the 5's cross off. That's for only multiplication. You don't do it for equals, right? You cross multiply. So L equals 5W. Now, can I substitute? You bet. 240 equals 5W plus W. See how it becomes very smooth when I'm very methodical about it. 6W equals 240. W equals 40. Okay. And if W is 40, then I get L, which is 200. Now I have my perimeter. It makes sense. 200, 200, 40, 40, I get 480. Sweet. All right, all's good. All right, now let's move on to 16 and 18. And there's a lot going on here. Let's see. This might be a little too ambitious, these notes. The measure of the angles are an extended ratio given. Find the measure of the angles of a triangle. I like this. This is a good one. This is a good one. Okay. 16. First of all, let's draw a triangle. Just kind of a general triangle like this, right? We'll call it angles A, B, and C. What do all the angles have to add up to? Correct. Very good. Now let me show you a little strategy you can use here. If the ratio is 1 to 1 to 1, call it x, x, x. So x plus x plus x equals 180. 3x equals 180. X equals 60. You do the same thing for number 18. 2x, 3x, 4x. Why am I doing that? Because if you compare 2x, 3x, 4x, isn't it all the same ratio? 2, 3, 4. X, 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 1, 1, 1, 1, right? So, so what this means at 40, 60, and 80. For number 16, that was 60, 60, 60. Right? Because we've had 1, 1 to 2, 1, 1, 1 ratio, but 2, 3 ratio falls at 40, 60, 80.
So what do you get for X? We times it by that.
Correct. Right. So once I solve for X here, then I get 40, 60, 80. Because it maintains the same ratio, because 40 to 60 is 2 to 3. 60 to 80 is 2 to 4. 40 to 80 is 2 to 4, or 1 to 2. So you maintain, so that's just a little strategy you can use when you have like more complex ratio problems. I think for now, let's go and skip this last page because we're going to see this later on in the notes. So let's skip that last page. Let's move on to the second page. This is more on proportional analysis. And again, I'm only going to do the evens with you guys. And I'm going to skip the one about the map. Maybe. No, I don't like it. It's a little too complicated. Let's do 2, 4, 6, 8, 14. Okay. So number 2 is kind of a funny problem. So 6 over x equals 24 over y. Okay, fine. So you can cross multiply. Six y equals 24x, right? You can cross multiply. Does that make sense so far? Well, what does the question want? 6 over 24, right? Want 6 over 24. And then you divide by y. So what did I do from an algebraic perspective? What I did was I first cross multiplied. You guys should see that hopefully, right? I did this with this. Sure, of course, yeah. Then the next step was I multiplied both sides by 1/24th, or divide by 24. That's how I got the next step. I multiplied both because then these canceled. Because I want to try to get x up to, I want to try to get 24 on the bottom. Then I multiplied both sides by 1/y to truly get 6/24 all by itself. So that was the process I did. I cross multiplied, then multiplied both sides by 1/24th, then multiplied both sides by 1/y, or divide by 24 and divide by y, same thing. So it requires a little bit of nifty algebra that's happening here for number two. Sometimes we need to do that for getting a ratio that we're interested in finding. Now for number four. Okay. For number four, a little tricky again. You want this, right? This is not terribly obvious. And cross multiply, I don't think will really help us too much, to be honest with you. I wouldn't recommend that. I want to open your eyes up to creative ways of solving problems. This is probably is more in line with algebra 2, I'd say. But does that make sense, what I just did in red? What did I just do? I just broke apart the fractions. Why does that make sense? Because what if I created this initially? If I gave two fractions of the same denominator, how would you combine these two fractions? You get, like, what if I have 1/3 plus 2/3? What's 1/3 plus 2/3? 3/3, right? Or let me write on the board. What if I had this? What if I had we'll do bigger fractions. What if I had this? What would it be 5/6, right? Because we have the same denominator, add the numerators. So if I give you two algebraic expressions with the same denominator, I add those numerators, right? So what I'm doing is I'm just going backwards, right? I'm giving it a simplified form and breaking it apart into that. So hopefully, we can see that reverse way of breaking apart a fraction. Now, what's y over y? 1. So you get x taken out. Yeah, you get 1. So x over y plus 1. And we were told what x over y is. It's 5/11ths. Now, how do I change 1 to a fraction? Correct. And then you can make 11 or 11. Now you get 16 over 11. So what I've done was I got really creative with my fractions. This is a little more advanced, but it's good because you guys need to be exposed to this. This is it's this kind of fractions that really trip people up because I don't know how fractions are taught in middle school. I've not never taught middle school before, so I can't really make a claim of how it should be taught. But I will say that we do want to be very fluid with our fractions. Like, hey, let's break it apart. Let's make it a number, and let's combine fractions afterwards. So that's what number 4 is. It's a little bit advanced, but I want you guys to see that because I think it's important for you to see it. Number 6, is that a true statement? I would actually cross multiply first. And then divide by s. Sorry, let me keep the t there for now. And then divide by t. So it's very similar to number 2, right? I cross multiply t to x, y to s. Makes sense, right? Then divide by s, x t or s is y. Why am I doing that? Because tell me to do that. But tell me to put s in the bottom of the left side. Okay. And then I gotta get t to the other side, but I gotta divide by t. Now, is that the same as this expression here? Nope. So the answer is false. Jay, go ahead.
Kind of.
Of course, yeah, go ahead. Yeah, that's false. So questions. All right. Let's keep moving. So 8x equals 5y. Actually, I don't know why I'm doing that. Sorry. That was dumb. Let's look at this here. What does x y equal? 5/8. That's 1. So you guys saw what I just did again. I did the same exact thing I did for number 4, right? I broke apart x plus y over y as that, which you totally can do. Totally fair treatment. Because if you go backwards, you get back to the same thing. And as now I said, 1 is 1 over 1, right? Now, when you have two fractions that don't have the same denominator, what do? We find the least common denominator, which is 8 and 8. Will this be true now? Yeah, because I will get 13 over 8. Yep, 13 over 8 on the left side, right? 5 plus 8, you keep the same denominator, 13 over 8. The answer is true. Okay, then let's try 14. And this is where we're going to really get into the heart of the matter of similar triangles. When you have similar triangles, you want things to be in the same proportion. So if you think about it, I have this triangle here. Bless you. I have this triangle here. Okay, what did I just do? This is going to be huge because this is where people get stuck in similar triangles. You really want to decompose, break apart these triangles. So you have combined triangles, right? It's kind of looks like funny things that kind of play tricks in your eyes. How many triangles do I see here? Actually, there's in a way, actually, just 2. Yeah, just 2. Yeah, you do see 1, but you do see this one also. There's a way you can make it look like 3. I think we do it differently, but anyway, you have a small one, you have the big one. Now, what's happening here? It's not terribly obvious, but this should have been added to the diagram. What's happening here is that these are parallel. If these are parallel, these would have to be the same. And these have to be the same. And naturally, they share angle S, right? So whenever that happens, the sides will always be proportional. So if we think about it, what side corresponds to RS here? QS, right? See how these are kind of lined up? The left side of the triangles. What side corresponds to ST here? SU. So you say 3/7 equals 6/x. So this is the main concept for today. This is the crux of our lesson today. Looking at triangles that are similar in shape, but not necessarily exactly the same. Kind of like if you built a model airplane, like let's say it was actually to scale, like the I don't know if you're doing like a fighter jet, like maybe the window compared to the wing would be the same thing in real life, same ratio. Like maybe it's like 1 inch here, like 3 inches there. In real life, it's maybe like 3 feet and 9 feet. I don't know. I'm just making it up. I don't know much about airplanes, but it's very similar. You're just doing it's a scaled down version of the small triangle. That's all. Of the bigger triangle, sorry. So if you cross multiply 3x equals 42, x equals 14. So that's 14. However, since that is 6, what is that going to be then right here? So 14 is the entire thing of SU, but ST is 6, and this whole thing is 14. How much is left into U? I'm just asking 14 minus 6. 8, 830, that's all. Just 8. So that's the concept of similar triangles, is we're trying to compare the ratios of the sides. The sides will always be proportional. Um, let's try 13, because I think you guys need to see this again. And then we'll move on to the next page after that, because we'll see more of that on the next page. Okay, so let's kind of do the same thing. Let me draw this. B, C, D, and then the big triangle. A, C, E. So I'll call this whole thing X right now. I'll call this 42. Um, ooh, that's kind of tricky. Actually, let me take it back. We'll call CB X. That's X and 24. And that'll be X plus 12 and 42. So I've made X CB, fine. Now, this is the part that I care most about today. How do I set up the equation? How do I set up the proportion? So CB corresponds to what side over here? When I say corresponds, meaning it's not exactly the same, but it's in the same position. So CB is in the same position as what side here? No. This triangle over here. So CB is it similar to CE, EA, or CA? CA, exactly. That's what's trying to correspond. So I'm not very clear about that. That's my fault. That's what corresponding means. It means that they are in the same position. Now, 24, that's CD, is in the same position as what side in the other triangle?
CE.
Correct. Good, good. And then you can cross multiply afterwards. So it's all about correspondence. That's what you're trying to do. Very important, you have to orient these triangles in a similar way and see how they correlate to each other. So it's kind of like the same thing as we said with ratios, right? Like you're comparing one thing to another thing, right? So in this case, 42x equals 24x. Yeah, because that's a pretty big number. 288, I think. So 18x. to get 16. And it does work, because if you compare the ratios, you'll get the same thing. Interestingly, the problems on the next page are actually a little easier. I don't know, seems kind of interesting, but we're gonna keep moving. Any questions so far? Nope. All right, let's keep moving. So, but that's what you have to do. You're looking at sides that correspond to each other. Okay. All right, so let's look over here now. Interesting, I think 6-3 should have come before 6-2. Bless you. Interesting, I felt 6-3 should have come before 6-2 because we're talking about correspondence, right? So first of all, you want to list all corresponding sides, or write the ratio of corresponding sides, and list all pairs of congruent angles. So when you have something like this here, the little squiggly line, that means similar. Okay, that means similar. So it means is that angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. So what it also means is that AB corresponds to DE. And likewise with BC and EF. And I don't feel like writing all these words again. And AC and DF. Angle A, angle B, congruent. B and E congruent. C and F congruent. Do you notice they're in alphabetical order? Not saying you should always put alphabetical order, but notice the order of the letters, right? Aren't A and D in the first letter in each triangle? B and C, same position, their second letters. C and F, same letters. That's done deliberately. I told you, we're OCD as mathematicians, so you have to be mindful about that. Look at AB. A to B, B to E. A to the first two letters, D are the first two letters. B, C, E, F, those are the last two letters, right? A, C, D, F, first, third letters, right? We see that, right? We see that. So what this means is that we expect these ratios to happen. So when you have to write corresponding ratios, you're gonna write AB over DE equals, I know I'm doing odd now, whatever, it's fine. I felt I want to do a triangle anyway. That is what is happening. Okay, that is what is happening. Would you agree AB is the shortest side in that first triangle? Would you agree DE is the shortest side in the second triangle? Yeah. Shortest, got to compare. Middle has to compare. Long has to compare. I would agree AC and DF are the longest sides in those two triangles. I'd agree that BC and EF are the middle sides in those triangles, right? You have to, like has to compare to like, right? That's what we gotta do. And what drives it? Corresponding angles being congruent. A and D are the same. B and E are the same. C and F are the same. What for like 40, 60, 80? We talked about that already, right? 40, 60, 80. You see the same angles in the other one. It just expanded. That's all. It's kind of like if you go to a copy machine, you expand something or you reduce something. You could do that in a copy machine. It's kind of the same thing. I'm not sure if that makes sense to you guys because you probably don't do photocopying. But anyway, it's expanding, reducing, whatever, right? So now let's talk about 5. So now we're gonna deal with this with numbers, right? Remember these symbols we talked about. These symbols mean congruence. Both right angles, B and B are the same, C and E are the same. So I could say triangle that little squiggly line does not mean congruent, it means similar. So, and how do I know that? Because here's the thing. AB to DF, doesn't that equal 3 to 6? And what's 3 to 6 reduced to?
1/2.
Correct. AC to FE. Oh crap, I wrote that similarity thing wrong. Crap. I would say this, guys. Sorry for slightly swearing. Okay. Not the best just given which is oh darn. The ABC FDE. My apologies. My apologies. Why did I do it that way? Because the right angles have to line up. The small angles have to line up. The other angles have to line up. My apologies. ABC and FDE. Please make that correction. That was bad. ABC is similar to FDE. So 3, 6 equals 1/2. Now let's look at AC and FE. That's 4 to 8. Is that still 1/2? Yeah. Let's look over here. BC to DE. 5 to 10, still 1/2. Okay, all's good. Okay. Okay. So the answer is yes, they are similar because they follow that ratio. The answer is yes. Let's skip down to 9 and 11. I know I'm doing the odds now, but I want to stick with triangles right now. Okay. So you're told these are similar. You're told that. STU, PQR. Okay. So ST over PQ must equal SU over PR. It's all for X now. Don't you get for X? What do you guys get? Yeah, perfect. Good. Pretty straightforward. Go and try number 11. I'm gonna give you guys a chance to work out number 11 on your own. Now you have an idea of what's happening. We'll call this X, by the way, and we'll call this Y. Now you have a general idea what's happening. Go and try 11. I'll check you guys in a moment. That's pretty steep. 9 to 12, 21 to X. Hope you guys, do you guys set up that way first? Good. You guys are seeing the connections now, right? Because remember, LN and PR correspond. LN is first and third letters, PR first and third letters, right? Oh boy, 9X. I cannot do that in my head. Can I do it in my head? 210, 252, I think. 121. Yeah, 252. Divided by 9. You should get 28 for X. And then also say 9 over 12. Should reduce 9 over 12 to make my life easier. 15 over Y? Yeah. So 9Y equals 180. Y is 20. Yep. So hope that those all make sense. Okay. Let's take a break. It's almost 10 o'clock, but we made some great headway here. These notes are a little too ambitious, so we'll come back at 10:10. So there we go. Yeah. So if M goes with G and O goes with H, then N goes with I, I'm going to say triangle GHI. And MN goes with GI. ON goes with HI. And MO goes with GH. And see how 16 and 12 line up? So then X and 10 have to line up. Or if I reverse it, See how 12 to 16, then therefore 8 to y. So of course x will equal 160 equals 12x. What is that going to be? I get 13.3 repeating. Here, 12y equals 128. That'd be 10.6 repeating. So that's what's happening with that one. I know I did all those problems here, but it was good to do. So again, you have to look at the corresponding angles. M goes with G, O goes with H, N goes with I. They have to go in that order, and you set the proportions in that way. So now we're going to determine if these are similar or not. So what I want you guys to do is figure out the missing angles. You guys should know all the angles out to 180. So it's kind of extension of what we did yesterday, right? All the angles out to 180. And we're going to answer whether they're similar, not similar, or cannot be determined. So you'll need a calculator. So if you want, there's some calculators in the back. That little bin there, that's kind of clear. Or if you have your own calculator, that works too. So I want you to find the missing angles, and then we got to make a determination if they're similar. If they are, we're going to say how they're similar. Yeah. No. Okay. So yeah, we all have out the 180. So let's add those two first. So what does that add to? So it'll be 31 degrees. Because so yeah, right. See that? Correct. Yes. Now find angle D. Do the same thing. Or it's 180, 47, correct. So it's pretty clear not all the angles line up. Because you have 9.4, you have 19.7%. The answer is that, not 70. Because all the angles have to be identical, all the corresponding angles have to be identical. Correct, yes.
Okay.
Right, you'd have, if you're stuck with this, you better have the same thing here.
Okay.
9231 and 57, but we did not. So unfortunately, it's not similar.
Okay.
Yeah. So guys, so nine should not be similar. Because angle C was 31, the angle D was 47.
How do you do 11?
Can't determine it. So, but before we get that, look at 10. 7748. That's one. Yeah, so you get 55 degrees here. Here you get 77 degrees. Yep. So that's yes. Similar.
Kind of.
They will be. Yep. Yep. For 11, you should have 43 degrees here. I think. But here, we don't know. So it can't be determined. We just can't tell because we don't have enough information for that second triangle. Does that make sense? Because if that's 43, but I don't know how to break apart. I know there's 137 left for both these angles, but I don't know how to break it apart. There's not enough information. I just don't know. Now, if I told like maybe it's isosceles, sure, then the angles have to be the same. They're opposite each other. That's the case for 12 though. If that's 90. You see these markings here? When these markings are identical, then these are identical. How much is left for these two angles if that's 90? Yeah. And how happens when we split 90 equally? Right, 90 by, see, use the calculator if you need to, but it's 45, 45. Now, let's look at the other one here. Look at the markings. These are markings for the sides. These sides are the same. These sides are the same. The angles opposite must also be the same. Call it a sausage triangle.
Also 40.
Also 45, yep. So the answer is yes for number 12. So yes, also similar. Okay, let's do a bit more here. Actually, I'm gonna have you guys figure this out on your own. You guys could do it. Let's start with the top three. So try to find missing angles if you can. If you can. And once we do, we'll write a similarity statement. Okay, what do you get for angle O? Yeah, remember the markings. When you have two sides are the same, the angles opposite them are also the same. Angle O is opposite NM. Angle N's opposite MO. Those have to be the same. So you get 142, therefore this is 38 degrees. And you want to get the same thing here because you have 38 there. You got to split equally. 142 split equally 71, 71. Bless you. Now look at 14. What's the measure of angle W? 60. Here's the problem with the other triangle, KLM. Do I know? I have no clue. No clue. So this is no. This is yes. Triangle NMO will be similar to triangle QRP because you have to make sure the angles line up. So you make a similarity statement, make sure the letters line up, that each letter corresponds to a congruent angle. Okay, take a look at 15. These are both equal out triangles. So angles DFG are all the same, right? These are all 60 degrees. Likewise, the other triangle too. So the answer is yes again. And you can write like this: triangle DFG is similar to triangle. You could, it doesn't matter because they're all the same. You can write however you want. RST. You just have to make sure each letter corresponds to a congruent angle. Okay. And then let's go and try the last three. And then I'm going to kind of pick and choose for the next set. So I'm going to reorient these triangles for you guys. I'm going to reorient it like this. Notice what I just did. I broke apart triangles like that. So try to look at 16 like that. And then for 17, kind of run out of space here. You can think of it like this. Those are the same. Just switch colors. How do I know that? Because you have parallel lines, right? But let's look at 16 first. What's the measure of angle A? 28. What's the measure of angle C? So yes. The answer is yes. I'm going to say triangle ABE. So you have to make sure that everything lines up. It's similar to triangle DBC. This is a little tricky. Okay. It was a little trickier for 17. Let me. I hope I didn't thoroughly confuse you guys with this diagram. You guys okay with 16? Why that makes sense, right? I just reorient. I took AB, I rotated it 90 degrees. We're gonna do a lot of rotations in geometry as well. I just rotated it and made sure it corresponded correctly with the other triangle DBC and saw how that worked, right? Okay, you guys see what these are the same? What do we call that when these are the same? Start with a V. Vertical angles. Or opposite angles is fine to say that too. That was always be right. Now, why is V and W the same? These are all parallel lines, right? Remember we had parallel lines, we had a line that went through it. So what if I extended? I know it's really tricky. What if I extended? And let me erase the other stuff here because now it's getting kind of messy. Okay. You guys see what these are saying? These are also triangles. And once you have two pairs of angles that correspond are the same, the third pair naturally have to be the same too. Like they have like say 40 and 60, that's 80, that's 100 each. So I want to combine, the last thing will have to be 80. So you kind of think of it, this corresponds to this. This corresponds to this. Right? Because it's both angle Y. So naturally, X and Z would have to correspond too, right? So just do my best to color code here. Those are also alternate to your angles. So it's really a close tie to parallel lines. So the answer is yes, again. And you can write it like this. I mean, there's not just one way to write it, but you have to make sure it's consistent. The triangle WYX. All is good? All right. Last one, 18. You could look at like this here. Let's break it apart like this for 18. SRT. And SQU. Now those have to be the same because if I were to extend these, right? Aren't those corresponding angles? Right? U and T. Those corresponding angles. Likewise with Q and R. And naturally S is shared, right? So the answer is yes again. So triangle RST is similar to triangle QSU. You got just make sure you go in the proper order. RST to QSU. Again, stuff we're covering right now, we're gonna see it again in the year, and you don't quite see it kind of as intense as not as intense, but it's like so much in one day. But yeah, but it's still something that we want to be comfortable with. Okay, so questions. Nope. All right. So now let's do here, and we're gonna just do the evens. So you're gonna verify if these are similar or not. Actually, let's do the evens again. All right, so let's take a look at AB to DE. 21 out of 28. And let's also compare it to, say, BC to EF. What does each fraction reduce to? Yeah, you get 3/4 and 3/4. So the answer is yes. So we're going to try 4 and 6. Yeah, let's do 4, 6, 10. Because there's 7, it got skipped. And 12 and 14. Okay, so 4, 6, 10, 12, 14. Let's talk about it. Which set of triangles do you think are similar? Which one would follow a consistent ratio? Well, let's look at the first and third. If you look at the first and third ones, right? AB to GH. Isn't that 24 to 30? So that's 4/5. Let's look at BC to HJ. That's 16 to 20. That's also 4/5. And lastly, let's look at actually I feel there's like I think they're all similar. That's confusing. Which two of the three? I think they're all similar. Do you guys get that? Yeah, that's weird. I don't like the instructions. That was confusing. Yeah, AC to GJ. That's 20 out of 25. That's 4/5 also. Yeah, that should be. Yeah, I think all of them were. Yeah, so the scale factor just means the ratio they're in. Um, so 2025. So for example, for triangle ABC, which is similar to triangle GHJ, you're gonna say it's a 4 to 5 ratio. That's what you're gonna say. Okay, for 6, we're gonna say 16 to 28, 12 to 21. So that's 4 to 7, divide by 3, 4 to 7. And that's a scale factor. It's 4 to 7. But oh, from the other way around, sorry. You're gonna say 7 to 4. Because you're doing big to small. Because RC is bigger than XYZ. So you say 7 to 4. For 10, we already saw this. Yeah, we already saw this. We should know that's 33. No, hold on. 31 and 47. So the answer is no. Yeah, we already saw that one. We know. And then 12 and 14. Um, yeah, if you think about it, if I reorient the smaller triangle like this, you can see in they're a 2-to-1 ratio. And they share an angle in the middle. So that's also another thing we could look at too. When it's shared, we call this side angle side similarity. That's a possibility we could have. When the side angle sides line up. And if I have a 14, if I flip over that one, so if you look at the ratios, 9 to 6 and 6 to 4, right? Because these have to line up. and these line up. Oh, cool, we got all done. Good timing. Yeah, so and you're gonna say was that? Oh, sure, yeah. So you could say that's a 3:2 ratio. And that triangle ABC is similar to triangle XYZ. Okay, I'm gonna skip because I think it's a little too much. So let's just go to this right here and just solve some of these for the last few minutes. So if you go near to the end of the last page here, or last sheet, we're just gonna kind of just work on solving these. I'll give you guys a few minutes to kind of do 1 through 6, and if we have time, maybe do some of the other page. In the meantime, I'll give you guys the homework, but we're just good. That's where we're going to just solve these proportions. And tomorrow, just we'll try to wrap up Delta Math. If we can do Delta Math tonight, get it all done. But some of you guys are pretty darn close. So tomorrow will be time for that. We're also going to do review tomorrow for our post assessment. Just see Jake just did in like a half hour, so it's too bad. Maybe 40 minutes. I'm going to handle the homework, so let's have it. You might just have the answers also on so it's not too great. Guys, I did all that. Cross multiply every time, right? You're allowed to do cross multiplication when there's just one fraction on each side. You're allowed to do that. And if you solve for each case, you should get the following. Don't worry about reducing it. Or actually, or getting decimals. Actually, I will reduce this one. It's 11 halves. Okay, so hopefully that seems to make sense, right? We got a little time. We could probably wrap up. Maybe just do the last couple. So 5n equals 3n plus 3. 9R equals 4R minus 40. Those make sense? Okay, just like a little more time. Well, let's guys do the last page and we'll wrap it up. So last page, 9, 9, 10, 11, 12. I think you just knock this out really quick. Homework's been passed out. Obviously, Jake, you don't have to worry about it. You're not here to do what, so. And there you go, that's the way it's. And then also it's subordinate. That's time to wrap up. You guys have that. You guys are good.
Yeah.
See you guys tomorrow.
Thank you.
Thank you.